2002 National Electrical Code permits the installation of polyvinyl chloride conduit inside walls, including block walls. Section 352.10 Atwo of the 2002 NEC specifies that polyvinyl chloride conduits are permitted to be installed in walls in accordance with sections 300.21 and 300.22, where the walls provide a thermal barrier equivalent to that provided by a 2I or fire-rated wall. This requirement is crucial because polyvinyl chloride conduit can release harmful vapors when subjected to fire. Preventing these vapors from entering occupied spaces is paramount. To meet the 2I or fire-rated wall equivalency, there are several methods to implement. One approach involves utilizing fire-resistant sealant around the conduit penetrations where it enters and exits the wall. Another method is to encase the conduit within a sleeve constructed of fire-resistant materials such as metal or concrete. It's essential to avoid installing polyvinyl chloride conduit in areas susceptible to extreme heat or direct flames. Keep polyvinyl chloride conduit away from furnaces and other heat-generating appliances. Adhering to these guidelines facilitates the safe and compliant installation of polyvinyl chloride conduit within block walls in accordance with the 2002 NEC. Section 300.21 addresses the spread of fire and products of combustion. Electrical installations shall be installed in a manner that minimizes the spread of fire or products of combustion. Electrical equipment and wiring shall be installed such that the fire-resistant rating of fire-rated walls, partitions, ceilings, and floors is not compromised. Section 300.22 covers wiring in ducts, plenums, and other air handling spaces. These spaces are used for environmental air. Cables and conductors installed in these spaces shall be listed as suitable for the purpose or installed in metal raceway. Firstly, ensure the block wall provides a thermal barrier equivalent to a 2I or fire-rated wall, as specified in Section 352.10 Atwo of the 2002 NEC. This is crucial for preventing the spread of harmful vapors in case of a fire. Secondly, seal around the polyvinyl chloride conduit where it enters and exits the block wall using a fire-resistant sealant. This helps maintain the fire resistance of the wall and prevents vapors from escaping. Thirdly, consider installing the polyvinyl chloride conduit in a sleeve of fire-resistant material, such as metal or concrete, to provide an additional layer of protection against fire and vapor release. Fourthly, avoid installing polyvinyl chloride conduit in areas where it will be exposed to extreme heat or flames. Maintain a safe distance from furnaces, heating appliances, and other sources of high heat. Fifthly, consult local building codes and regulations to ensure compliance with all applicable requirements for fire safety and electrical installations. Local codes may have additional restrictions or requirements beyond the NEC. Sixthly, use listed and labeled polyvinyl chloride conduit and fittings that are suitable for the intended application and environment. This helps ensure that the materials meet industry standards for safety and performance. Seventhly, properly support and secure the polyvinyl chloride conduit to the block wall using appropriate hardware and methods. This prevents the conduit from sagging, shifting, or becoming damaged over time. Eighthly, protect the polyvinyl chloride conduit from physical damage during and after installation. Avoid exposing the conduit to impact, abrasion, or other conditions that could compromise its integrity. Ninthly, inspect the installation regularly to identify and address any signs of damage, deterioration, or non-compliance. Promptly repair or replace any damaged components to maintain the safety and performance of the electrical system. Tenthly, document the installation, including the types of materials used, the methods of installation, and any special considerations or precautions taken. This documentation can be helpful for future maintenance, repairs, or inspections. The NEC provides specific guidelines for electrical installations in various environments, including those involving fire-rated walls and air handling spaces. Understanding these requirements is essential for ensuring the safety and compliance of electrical systems. The proper installation of electrical systems in fire-rated walls is crucial for maintaining the integrity of the fire barrier and preventing the spread of fire and smoke. Electrical penetrations through fire-rated walls must be properly sealed and protected to maintain the fire resistance rating of the wall. Wiring in ducts, plenums, and other air handling spaces must be suitable for the environment and installed in accordance with NEC requirements. This helps prevent the spread of fire and toxic fumes through the ventilation system. It's important to consider the specific requirements of the NEC as well as any local codes or regulations when designing and installing electrical systems in these types of environments. Consulting with a qualified electrical engineer or inspector can help ensure that the installation meets all applicable requirements and is safe and compliant. When installing polyvinyl chloride conduit in block walls, it is essential to consider the fire resistance of the wall assembly. Block walls are often used as fire barriers, and it is important to maintain the fire resistance rating when installing electrical conduit. The NEC requires that electrical installations in fire-rated walls not compromise the fire resistance rating of the wall. This means that any penetrations through the wall must be properly sealed and protected to prevent the spread of fire and smoke. There are several ways to maintain the fire resistance rating of a block wall when installing polyvinyl chloride conduit. One option is to use fire-rated sealant to seal around a conduit where it penetrates the wall. This sealant expands when exposed to heat, filling any gaps and preventing the passage of fire and smoke. Another option is to install the conduit in a sleeve of fire-resistant material, such as metal or concrete. This sleeve provides an additional layer of protection against fire and helps to maintain the integrity of the wall assembly. In addition to maintaining the fire resistance rating of the wall, it is also important to consider the potential for the spread of toxic fumes in the event of a fire. Polyvinyl chloride conduit can release harmful vapors when exposed to high heat, and it is important to prevent these vapors from entering occupied spaces. This can be achieved by sealing around the conduit penetrations and by avoiding the use of polyvinyl chloride conduit in areas where it is likely to be exposed to extreme heat or flames. It is also important to follow all applicable NEC requirements for the installation of electrical conduit in fire-rated walls. These requirements are designed to ensure the safety of building occupants and to prevent the spread of fire and smoke. In National Electrical Code Section 300.21 is about preventing the spread of fire and products of combustion. It's a critical section that focuses on maintaining the fire resistance rating of walls, partitions, ceilings, and floors when electrical installations penetrate them. The main idea is that electrical work shouldn't compromise the fire safety features of a building. Think of fire-rated walls as barriers designed to slow down or stop the spread of fire. If you poke holes in these walls for electrical wiring or equipment, you need to make sure you seal those holes properly to maintain the wall's fire resistance rating. Products of combustion refer to smoke, toxic gases, and other harmful substances released during a fire. Electrical installation should be done in a way that minimizes the spread of these products throughout the building. Using fire-resistant sealants and materials is key. When running cables or installing electrical boxes in fire-rated walls, use sealants and materials that are specifically designed to resist fire. These products expand when exposed to heat, filling gaps and preventing the passage of flames and smoke. Proper installation techniques are also essential. Make sure that any openings around cables or conduits are completely sealed. Follow the manufacturer's instructions for the fire-resistant materials you're using. Local building codes often have specific requirements for fire-stopping electrical penetrations. Be sure to check and comply with these codes. Regular inspections can help identify any potential fire safety issues related to electrical installations. Look for gaps or cracks in fire-stopping materials and address them promptly. Section 300.22 of the National Electrical Code focuses on wiring methods and materials allowed in ducts, plenums, and other spaces used for environmental air. The primary concern is to prevent the spread of fire and toxic fumes through the air handling system. Plenums are spaces above suspended ceilings or in raised floors that are used for air circulation. Ducts are channels specifically designed for moving air. These spaces require special attention because they can easily distribute smoke and fire throughout a building. Only certain types of wiring and cables are permitted in these spaces. These must be specifically listed for use in environmental air spaces or be enclosed in metal raceways. The reason for this is to minimize the risk of fire and the spread of toxic fumes. Cables that are listed for use in plenums are designed to be fire resistant and produce minimal smoke. These cables are typically more expensive but are essential for safety. Metal raceways, such as conduit, provide a protective barrier around the wiring. This helps to contain a fire and prevent the release of harmful substances. All materials used in these spaces, including cables, raceways, and electrical boxes, must be fire resistant and produce minimal smoke. This ensures that the air handling system remains safe in the event of a fire. Proper installation is crucial. Make sure that all wiring and equipment are securely fastened and supported. Avoid creating any obstructions that could impede airflow. Regular inspections are important to identify any potential problems. Look for damaged wiring, loose connections, or improper materials. Address any issues promptly to maintain the safety of the air handling system. Some local building codes may have additional requirements for wiring in air handling spaces. Be sure to check and comply with these codes. Polyvinyl chloride conduit is a popular choice for electrical installations due to its low cost, ease of installation, and resistance to corrosion. However, when it comes to fire safety, polyvinyl chloride presents some challenges. Polyvinyl chloride is a thermoplastic material, meaning that it softens and melts when exposed to high temperatures. This can compromise the integrity of the electrical system and create a fire hazard. When polyvinyl chloride burns, it releases toxic fumes, including hydrogen chloride gas. These fumes can be harmful to building occupants and can also damage equipment. Because of these fire safety concerns, the NEC has specific requirements for the use of polyvinyl chloride conduit in buildings. In general, polyvinyl chloride conduit is not allowed in plenums or other air handling spaces unless it is specifically listed for that purpose. It is also important to protect polyvinyl chloride conduit from physical damage, as this can increase the risk of fire. In some cases, it may be necessary to encase polyvinyl chloride conduit in concrete or other fire-resistant materials to provide additional protection. When installing polyvinyl chloride conduit, it is important to follow all applicable NEC requirements and to take precautions to minimize the risk of fire. This includes using proper installation techniques, protecting the conduit from damage, and avoiding the use of polyvinyl chloride in areas where it is not allowed. Proper support of polyvinyl chloride conduit is crucial for ensuring the long-term reliability and safety of electrical systems. Polyvinyl chloride conduit is a flexible material, and if it is not properly supported, it can sag, bend, or even break under its own weight or the weight of the conductors inside. This can lead to a variety of problems, including damage to the conduit, stress on the conductors, and potential fire hazards. The NEC provides specific requirements for the support of polyvinyl chloride conduit. These requirements vary depending on the size of the conduit, the spacing between supports, and the type of support used. In general, polyvinyl chloride conduit should be supported at intervals of no more than 3 feet for smaller sizes and 5 feet for larger sizes. Support should be designed to securely hold the conduit in place and prevent it from sagging or moving. There are a variety of different types of supports available for polyvinyl chloride conduit, including straps, clamps, and hangers. The type of support used will depend on the specific application and the type of mounting surface available. It is important to choose supports that are compatible with polyvinyl chloride and that are designed to withstand the weight of the conduit and conductors. In addition to following the NEC requirements for support spacing, it is also important to consider the environment in which the conduit is installed. In areas where the conduit is exposed to extreme temperatures or weather conditions, it may be necessary to use additional supports or to use supports that are designed for those conditions. Proper support of polyvinyl chloride conduit is essential for ensuring the safety and reliability of electrical systems. By following the NEC requirements and using appropriate supports, you can prevent damage to the conduit, reduce stress on the conductors, and minimize the risk of fire hazards. When installing electrical conduit in block walls, it is crucial to consider the proper techniques for creating penetrations. Block walls are often used as fire barriers, and improper penetrations can compromise their fire resistance rating and allow the spread of fire and smoke. Before making any penetrations, it is essential to identify the location of any existing utilities, such as electrical wiring, plumbing, or gas lines. Damaging these utilities can be dangerous and costly. Use appropriate tools for drilling or cutting through the block wall. A hammer drill with a masonry bit is typically the best choice for creating clean and accurate holes. Avoid using excessive force, as this can damage the block and create cracks. When drilling or cutting, wear appropriate safety gear, including eye protection and a dust mask. Block walls can produce a lot of dust, which can be harmful to your health. After creating the penetration, inspect it carefully for any cracks or damage. If any damage is found, it should be repaired before installing the conduit. To maintain the fire resistance rating of the block wall, it is essential to seal around the conduit where it penetrates the wall. Use a fire-rated sealant that is specifically designed for this purpose. Apply the sealant generously to fill any gaps or cracks around the conduit. Proper installation of electrical conduit in block walls requires careful planning, the use of appropriate tools and techniques, and attention to detail. By following these guidelines, you can ensure that the installation is safe, compliant, and does not compromise the fire resistance rating of the wall. When selecting electrical conduit for a specific application, it is important to consider the different types of conduit available and their suitability for the environment and conditions in which they will be used. Electrical conduit is available in a variety of materials, including polyvinyl chloride, electrical metallic tubing, rigid metal conduit, and flexible metal conduit. Each type of conduit has its own advantages and disadvantages, and the best choice will depend on the specific application. Polyvinyl chloride conduit is a popular choice for many applications due to its low cost, ease of installation, and resistance to corrosion. However, polyvinyl chloride is not as strong as metal conduit and is not suitable for use in areas where it will be exposed to physical damage. Electrical metallic tubing is a lightweight steel conduit that is easy to bend and install. Electrical metallic tubing is suitable for use in dry locations and is often used for branch circuits and lighting. Rigid metal conduit is a heavy-duty steel conduit that is strong and durable. Rigid metal conduit is suitable for use in wet or corrosive environments and is often used for service entrances and feeders. Flexible metal conduit is a flexible conduit that can be easily bent around obstacles. Flexible metal conduit is suitable for use in short runs and is often used to connect equipment to electrical boxes. In addition to the type of material, it is also important to consider the size of the conduit. The size of the conduit will depend on the number and size of the conductors that will be installed inside. The NEC provides guidelines for the proper sizing of conduit to ensure that the conductors are not overcrowded and that there is adequate space for heat dissipation. Selecting the right type and size of electrical conduit is essential for ensuring the safety and reliability of electrical systems. By considering the environment, conditions, and the number and size of conductors, you can choose the conduit that is best suited for the specific application.